Good evening. Now I'm going to take a seminar on scaffold fabrication techniques. First, I'm going to introduce what is tissue engineering. Tissue engineering is a interdisciplinary field that utilizes cells, biomaterials, biochemical, example growth factors, and physical, maybe mechanical loading signals, as well as their combinations to generate tissue-like structures. The main goal of the tissue engineering is to provide biological substitute that can maintain, restore, or improve the function of the damaged tissue. The first tissue engineering skin product was developed in late 1970 and early 1890, but the modern tissue engineering was only arise in 1987. The main components of the tissue engineering were scaffolds, cells, and growth factors. Above this, the scaffold plays important role in the tissue engineering. The various scaffold fabrication techniques are chemical vapor deposition, template synthesis, melt blown, drawing, and electrospinning. First, we will see the chemical vapor deposition. Chemical vapor deposition is a deposition method utilized for the fabrication of the solid material with high quality and performance, typically under vacuum. In this process, the substrate is exposed to the volatile precursors at high temperature, resulting in the decomposition of the substrate surface to form thin film. The next, fiber drying. Fiber drying is a common method used for the nanofiber production. Here, a solid tip is immersed in the molten polymer and then drawn away. The drawn needle leaves with the polymer wire that is quickly pushed in air, and finally the nanofiber is fabricated. The next is self-assembly process. Self-assembly process refers to the autonomous group of components into pattern or structures utilized for the fabrication of nanofibers. The grouping may be done with the help of non-covalent bond or covalent interactions. The interactions may be van der Waals, electrostatic, ionic, hydrophobic interactions, hydrogen, and coordination bonds respectively. The next, template synthesis. In template synthesis techniques uses the template that refers to the metal oxide to obtain a nanofiber. The polymer solution is passed through the nanopores of the metal oxide, resulting in the extrusion of the polymer under the application of water and the pressure on one side. The extruded polymer is allowed to contact with the solidifying solution, converting them into nanofibers. The next is melt blown technology. In melt blown technology, the nanofibers are fabricated from the fibers or resins using high velocity air. The components involved in the technique were die assembly, extruder, metering pumps, web formation, and winding. Here, the polymer weld was performed using extruder and then feed to the melt blown die. In that die, the high velocity hot air stream converts the polymer melt into microfibers. Finally, the surrounding air cools solidifies the fiber, resulting in the self-bonded non-woven web. This is the schematic representation for a melt blown technology. Here, the polymer is fed in the top and bottom, or the hot air will be made to fall on the fiber, which makes the polymer to convert into the fibers, and then it is deposited on the collector. The next finally is the electrospinning technique. Recently, the electrospinning technique is widely utilized techniques for the fabrication of nanofiber. In this technique, a high voltage was applied to the polymer solution and converted into nanofibers. The components involved in the electrospinning were syringe pump, applied voltage, and connected drum. The first droplet of polymer solution is extruded from the needle as a result of surface tension. On applying electric field, the droplet was first converted into cone. On further increase in the electric field, the charge jet was converted into nanofibers and then collected on the collector. This is a schematic representation. The syringe pump loads the polymer, which ejects the polymer. On applying voltage, the polymer solution was converted into nanofibers and deposited on the aluminum foil on the collector drum. Thank you.